Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a repeat customer. This is the NAD 7225 PE for power envelope. This one was featured in episode 170. It is back because it has an issue, or the owner says it has an issue. He says the channel balance is really going out of whack now. One channel is quite a bit different than the other. So yeah, is that what is going on with that? So when I went back and reviewed the video of what I did in history, and I did a full recap, did a lot of things. When I went through the power tests at the end of the video, I did notice that the right channel went into clipping a little earlier than the left, which showed a little bit of an imbalance, but it wasn't really that bad. It wasn't really noticeable. But he says it's noticeable now, so I don't know if this is something that just creeped up over time or something that came suddenly. We don't know yet. Now typically when you get a really bad channel imbalance on an amplifier like this, or an integrated amp, is probably one of two things. Well, could be a number of things actually. If you got relays, speaker relays, side could be failing and providing high resistance, which would cause the channel to go down in volume. But typically it's just two things. It's either the balance pot or the volume pot is failing. Aside from that, it could be switches, it could be a lot of things, it could be caps, but we did put new caps in this, so I don't expect it to be anything wrong with the internals other than one of these two. So we're going to do a little bit of testing here to make sure we confirm that it does have a fault. And once we confirm it has a fault, we're going to try and track it down and see where it's coming from. So I got it wired into a 8 ohm load. I got a tone signal source going in into both channels. It's both equal. It's a mono signal to both, so they are equal going in. And let's connect the scope up, and we'll have a look at what's coming out, and we'll see how bad the imbalance is. My second camera going so we can watch the scope. Alright, so let's power this thing on. And see, our consumption is right around 21 watts. I remember that was... So, okay, let's turn this up. We got our signal. Let's see what we have here. Looks pretty balanced. Maybe the right is a little bit higher. Let me switch my probes. Alright. Let's keep going up. Okay, there's our clipping. And the right comes into clipping a little sooner than the left, which is exactly the way it was when it left here last time, from what I reviewed on the video. And it looks like, to tell you the truth, it looks like they're both even. Even Steven. Let's try overlapping each other. A little bit of discrepancy there. Let's go down. Yeah, I don't see a huge imbalance. It looks pretty good to me. Balance control. Yeah, I don't see it. Power supply is making funny noises. Okay, it is a little bit off because if I go right here, we're probably sitting at around 11 o'clock position. And those The right is a little higher. But you shouldn't really notice that in normal listening. I don't think it's that bad, to tell you the truth. Okay, let's see what we can do about this. Alright, let's look at the schematic here, see if we can figure out what's going on here. So we have all our inputs here, and most of them flow through, but the phono ones don't. The phono ones go through the phono equalizer amplifier, and then it comes out at the other end. And then here's all our switching for our function switches. We have video, CD, tape, phono, AM, FM. So that's all the switching here. So everything in this area, nothing's really going to happen. We do have some resistors here on all the inputs, 1K, 1K. I don't think defective resistor would cause an imbalance in this because we got high impedance circuits here. Let's go look further. So after the function switching comes out, I think this is your mono switch. This switch here I think is our loudness because it switches in a filter. The capacitor and resistor is part of the loudness. And then it goes into the volume control. R339A, R339B, which is 20K. These volume controls have a center tap that is for the loudness circuit. So yes, that is the volume. And then we have our wiper on this side that goes from 0 all the way up to maximum, 0 being grounded. So we can check here and here with a voltmeter to see if we have equal signal. I have a feeling we will, unless one of these potentiometers is out of whack. But then it goes through a preamplifier circuit, and we've got a simple 4 transistor circuit here. 1, 2, 3, 4, and then our output through this capacitor, and then it goes here. What is this? This is our tone controls? I think so. Kind of odd way of doing things. And then it goes through a 560 ohm resistor, through a FET. These are muting FETs, so that when the mute circuit comes on, these FETs they open up. And then it goes to the output, which is a balance pot. And then we have a balance pot that has a center tap grounded, and then we have the wiper is grounded. So depending on where the wiper is, it's going to allow signal through either both or one of the channels. And I have a feeling that our problem lays right here on this balance pot. So what I'm going to do is I'm going to take some measurements between the center tap and each leg of the pot, and we're going to see if we have a balanced pot. It's a 20K pot, so we should have 10K on each side, and we'll see how far out of balance that is. And if that's our problem, then we can easily correct this just by adding resistors to bring it back into balance. So let's try that right now. Alright, so here's our balance pot, and you can see this trace that comes out the top here and goes around down to the board. That's our center tap. So, and then we have 1, 2, 3 underneath connections, so there's 4 connections altogether. Let's measure from the center tap to, oops, didn't get prepared here before I turned the camera on. So let's measure between center tap and, oh, we've got to get a meter in frame too. That should work. Now I can't see. See what kind of troubles I have. Let's do this. Alright, let's do this. Alright, so I want this one here. Center tap. Is my hand going to be in the way? Probably. So what do we got here? We have 5.02K. That's where it settles. Okay, let's measure this side. I can't see it. $4.88K. So we do have an imbalance here. So what I propose to do is add a resistor on this side here to bring this down to 4.88K. And let's see, I'll have to do the math. Yeah, let me see if I can do the math, and then we'll figure out what a value resistor we should have, and then I'll see if it's correct. Okay, now we have a little problem here. This is a 20K pot, and what I measured there, I measured 4.88 on one side, okay, and then 5.04, I think it was, K on the other side. That doesn't add up to 10. That doesn't add up to 20K. This should be 20K here. So I think there's some external forces going on here. And if I look here and here, these two transistors should be open when they're not turned on. I think that's part of the muting circuit. If I look here and here, it goes straight to the power amplifier. Here and here. And here we have a couple of 220K resistors hanging off the inputs. So this is going to load down my meter. It's going to make a difference. So what I'm going to do is I'm going to pull these jumpers, and I'm going to redo the measurements and see if we still have those same numbers. Okay, so here's what we got here. We got a balance pot. Draw the resistor element. Here's our wiper. And here's our center tap. Now we measured, what did we measure? On one side we measured 4.88K. The other side we measured 5.04K. I don't know how accurate that is. But that's between here and here and here and here. We're not worried about this because it doesn't matter where this is. We're worried about what's grounded here. This is ground. And this is going to set the balance point for this potentiometer. So we want these two numbers to be equal. Otherwise, we have an imbalance. So how do we do that? Well, the way we could do that is by adding a resistor here to shunt this down from 504K to 4.88K. And what's this value going to be? We don't know. So let's go calculate it and figure it out. Alright, so here we're on the DigiKey website. So what are we doing on the DigiKey website? Well, they have a good section here. It's called Resources. It's right in the main menu. If you click on Resources and go down to Tools, you have conversion calculators. You got all kinds of different things that will help you along. The conversion calculators are excellent because I use this all the time. And it just saves you from doing hard math. And yeah, there's a lot of calculators you might find useful, so go have a look at it. The LED one I like. I always use that one. It's down here, you can't see it. Let me show you. Down here there's an LED one, and that's for calculating series resistor for LEDs. But the one we're interested in right now is this one here, this parallel and series resistor calculator. So let's click on this one, and it's going to open up a calculator for us. Let me reframe this. Okay, so what we got is we got our circuit, and we know what R1 is. We know what we want for Rn, but we don't know what we want for R2. This is unknown right now. There's formulas for this, but I can't remember what they are. So first thing we should do is let's change all of these to kilo ohms. Change this one to kilo ohms because we're going to work in kilo ohms. Okay. Now what we want is to put the first value resistor in, and that's 5.04. Okay. and then down here at the bottom it shows what the resistance is. But we want this resistance to show 4.88. So what we're going to do is we're going to add a resistor in here. Let's start with 100k ohms. So we'll put 100. And already you can see this dropped to 4.79k. That's a little too low. So we want to go higher on this one. Let's go 120. This is just a quick and dirty way of doing it. 120. And it shows 4.83. Well, we're still too low. So let's go up one more value. Let's go up to 150k. 150. And bang, here we are. We're at 4.88 now. So this is good. So if we have one side of the potentiometers reading 5.04 and we add 150k resistor in parallel with it, we're going to end up with 4.8762k ohms, which should be equal to the other side of the potentiometer. So then we have our balanced pot. So now we know our value. So let's go do that. Alright, here's the underside of the volume pot, or balance pot, sorry. So it's set to the center. Here's our 4 connections. So this one here is our center tap. This one's our right connection, our wiper, our left connection. So whichever one has the higher resistance, I have to check here. We got a meter. I think it's the one on the left here. Let's see. Is it this one? $514, and then this one here should be 4. Yeah, I have those jumpers pulled. That's why we're getting different readings now. So I need to add a resistor between these two terminals. So let's do that. I get a 150k resistor. And we need to make a spot. Let's make a spot here. Scrape back some of this solder mask. We'll just solder it right to the board. Make it inconspicuous as possible. I think that should be good. Okay, we'll go to 150k resistor here. Okay. Let me wet one of these pads. Can you see this? I hope you can. Okay, let's do this. Okay. All right. Solder this side. Didn't quite scrape off enough. It's there. All right. Let's see what we got now. We should have a balanced pot. So let's measure from this side. What do we get? $4.097. This side it's a lot better. It's not perfect, but I think this is going to be good enough for us to get back in track with our outputs. Okay, let's test it. Okay, let's test this out since we made the mod, and let's see how it works. Got it plugged in here. Alright, turning it on. We have our same signal source, same. Let's turn it up. Looks like it's fixed. Well, maybe not. We're still a little bit out. Very, very slight amount. It is actually better. So if I rotate the balance pot right here, yeah, it's improved. I wonder if I could make a little bit more changes. Because, let's see here. Let's go drive this into clipping. Yeah, they both start around the same time. Interesting. Okay, superimposed on top of each other. If I rotate the balance, it's very, very slight difference. Yeah, it's very, very slight. I wonder if you could even measure that. Left channel, 202 millivolts. Right channel, 202 millivolts. And that's with the balance controlled. Slightly cocked to the left. So if I go like that, we got 205 and 202. What is that? It's not even like a 1% difference. Well, there it is. It's done. I'm going to leave it like that. It is. It's still not perfect, but it's a lot better than when it came in. Now, I zeroed in on the balance pot because these balance pots with the center tap that goes to ground, they pose a problem, and if they're not perfectly balanced in resistance, then you're going to get an imbalance in sound. Could have been just as bad. It could have been just a bad volume pot, but in this case it wasn't. Volume pot would have been easy to change. Actually, no, you can't just replace these because they have the center tap, and try and find a potentiometer that has a center tap. Good luck. So next best thing is just add a resistor, balance the system out, and continue on. Now this might drift in time. This might get worse, so we might have to go back in and revisit this. I don't know, but for right now it should be an improvement for my client. So I'm going to wrap this one up. I know it's a short one, but that's all I got for today. So take care, and thanks for watching. We'll see you on the next one.